Okay, so this is 1.3b. This section's pretty tough because it does have a lot of application problems in it, so just make sure that you are focusing while you're working through this because it does take, a little bit of mental energy or whatever. So we're going to look at 5 questions here. So here's the first one. 2 brothers are saving money to buy tickets to a concert. Their combined savings is $55, and then they tell us some details about the brothers. So basically, let's write an equation for overall what's happening here. So basically, their combined savings is $55. So if I take brother 1 savings and add brothers 2 savings, it should give me $55. So what I need to go through and do is figure out variables for brother 1 and brother 2. If I can do that, I can plug them in here and solve this equation. So here's what they tell us. One brother saved $15 more than the other brother. And then how much does each brother save? So I'm going to pick one of the brothers. I'm just going to pick brother 1 and call him X. Now the other brother saved $15 more. So I'm going to call him X plus 15. So B1 is X, B2 is X plus 15. Let's plug them in. B1's X, B2's X plus 15. Now I want you to look at this. This is an equation we know how to solve. Actually, it's a pretty easy little equation. Combine my X's and then go through and solve this thing. So I'm going to subtract my 15 and 2x equals 40, x is 20. Now that means brother number 1 saved $20, brother number 2 saved 20 plus 15, so he saved 35. So one of them saved 20, the other one saved 35. Now, here's the key. What you've got to make sure that you do is write your equation. I would just leave in the brothers or whatever it is that you're talking about, then get your variables to plug in. If you can do that, it'll go pretty smoothly. Okay, so here's our next one. Find 3 consecutive numbers. Now consecutive means back to back, so 1, 2, 3 are consecutive. 45, 46, 47 are consecutive. Find 3 consecutive numbers whose sum is 126. So if I have number 1 plus consecutive number 2 plus the third one, they should all add up to 126. So let's get them in terms of x's then. So n1, n2, and n3. So I'm going to call one of them x. Now if they're consecutive, that means it's one number higher. So I'm going to call this x plus 1. And then I've got to go one number higher again, x plus 2. Now let's plug them in, and then we can solve for our answer. Okay, so I've got 1, 2, 3 x's plus 3. And then I'll go through and solve this thing. So subtracting my 3, I have 3x equals 123, x equals 41. So my first number is 41, which means my second number is 42, my third number is 43. Okay, I hope you're getting kind of the system here. Decide what you need to do, and then go back and get your variables set up so that you can plug those in. Okay, we're going to get a little bit harder now. Now, before we actually look at this problem, I want you to have this in your head. This little formula, you know this. Distance equals rate times time, because we're going to talk about a lot of distances in the next 3 problems. Distance equals rate times time. Now that makes sense. If you're going at 60 miles per hour and you drive for 2 hours, you've total gone 120 miles. It makes sense. Y'all know it. We just need to implement it here. Okay, so here is our question. Mike and Adam leave a bus terminal at the same time and travel in opposite directions. So one of them goes this direction, the other goes this direction. Mike's bus was in heavy traffic and had to travel 20 miles per hour slower than Adam's bus. After 3 hours, their buses are 270 miles apart. How fast is each bus going? Which means we are looking for the rate. Keep that in mind. Oops. Okay, so let's come up with our situation. If we have Mike's distance plus Adam's distance, that should give me my 270 miles. The other stuff we're going to use to get their variables equals 270. Okay, so let's get at our variables then. We're going to start with Mike, and then we'll deal with Adam. Okay, so here's what they tell us. Mike's bus was in heavy traffic and had to go 20 miles per hour slower than Adam. Now, it depends on who you decide to call X here. If I call Mike X, Adam was going 20 miles per hour faster than he was, which means Adam would be X plus 20. If you chose to call Adam X, Mike was going slower than he was. So either one's fine, just make sure you're consistent with it. Okay, now what I'm going to go through and do here is I need to put in my distance, which is rate times time for each of these guys. It should add up to 270 miles. Now, they are driving or on their buses for the same amount of time. Both of them are on there for 3 hours. So this time is consistent. It's the rate that changes. Now I know Mike's rate. I know Adam's rate. So all I need to do then is solve. So let me just clean these up. This is 3x. Here I'm going to distribute out my 3, so 3x plus 60, and then I've got my 270. So combining like terms, 6x plus 60 equals 270. I'm going to subtract my 60, so 6x equals 210. And if I divide, I don't actually have my calculator here, but if I divide, I will get 35. Okay, so Adam's time is 35, or his rate. Adam is 20 miles per hour faster, so he's 55. So Mike is 35 miles per hour, and Adam's 55 miles per hour. Now, on these, there are different ways that you can do them. For example, when I did this one originally in my notes, I made Adam X, which meant Mike had a different, variable there, but you end up in the same place. So it's okay if you set them up a little bit differently. All right, 2 more. So here's our situation. 2 trains left a station at the same time. One traveled north at a certain speed and the other traveled south. So one's going north, one's going south. Travel south at twice the speed of the other train. After 4 hours, the trains are 600 miles apart. How fast is each train going? Okay, now same thing. I know how far apart they are. So if I take train number 1's distance and I add train number 2's distance, I should get 600 miles per hour. And I want to make sure I do my distances in terms of rate times time. Okay, so let me plug in here the things that we know. We know the time. They're both traveling for 4 hours. I can put that in there. My work is going to be to write my rates in terms of a variable. I'm going to pick x here. Okay, so here's what they tell us. One train traveled north at a certain speed, so I'm going to call the first train x, his speed is x. The other one traveled south at twice the speed of the other train, so he's going 2 times faster. So if train 1's going at x miles per hour, train 2 is going at 2x, twice miles per hour. So let's plug those in. And now I'm number crunching. 4x plus 8x equals 600. So 12x equals 600. And I forgot my 0. X is 50. So train number 1 is going at 50 miles per hour, which means train number 2 is double that, so it's 100 miles per hour. It's a pretty fast train. All right, here's our last one. Okay, radar detected an unidentified plane 500 miles away, or 5,000 miles away. Okay, so here's the unidentified plane. It's 5,000 miles away from where we are. Approaching at 700 miles per hour. They gave us the rate this time. 15 minutes later, an interceptor plane was dispatched traveling at 800 miles per hour. They also gave us the rate for the other one. How long did the interceptor take to reach the approaching plane? So our unidentified plane's coming this way. The interceptor is coming this way. Their total distance is 5,000. So let's set it up. So the unidentified plane distance plus the interceptor's distance has to equal 5,000. And then let's do it in terms of rate times time is my distance. Okay, now here's what I know this time, different from before. I know the rates. The first plane's going at 700 miles per hour. The second plane's going at 800 miles per hour. And I know my distance, we already had that, it was 5,000. What I've got to figure out in terms of my variables is the time. So let's go through and let's think about this time. So I'm going to call the time that the unidentified plane is traveling, I'm going to call that x. Now the interceptor left 15 minutes later, which means 1/4 of an hour later. So that plane had 1/4, 15 minutes of an hour shorter time than the first plane. So I'm going to call the interceptor x minus 1/4 of an hour. I'm going to write it as a decimal here. Those are my times. Now I think I have them switched in terms of the order, in terms of what I have here. The unidentified plane was this one, so it's x. The interceptor is this one, it's x minus 1/4, or 15 minutes is 1/4 of an hour. Now I have my equation, so I'm just going to go through and I'm going to number crunch. Okay, and 800 times 1/4 is 200. And keep on going. So here I have 1500x. I'm going to add my 200. So when I add my 200, I'll have 5200 and divide by that 1500. So my x is 3.47 hours. Now I may have picked the wrong one to have been my x because they asked us how long the interceptor took. So I'm not sure wording wise if they mean they want the time that the interceptor traveled. If so, subtract off the 0.25 5 and you'll have 3.22.